Hello, my name is Tanya Maurer from the Monterey Bay Aquarium Research Institute in Monterey, California, and I'll be speaking to you today about data management for the GO-BGC profiling float array. This program was recently funded by the National Science Foundation and is a collaboration between Scripps Institution of Oceanography, University of Washington, MBARI, Princeton University, and Woods Hole Oceanographic Institution. I wanted to preface this talk by reminding you that BGC Argo floats, including those within the GO-BGC array, are really transforming the way that we do oceanography and the amount of data that we have access to and our understanding of global biogeochemical processes. But it still all starts with the ship. We deploy our floats off of research vessels, many along GO ship lines, with routine CTD casts and shipboard data collection. And while the shipboard data collection is not essential to float operation, it really plays a key role in data validation and quality assurance. So as we continue our discussion of data and data management, I'd like you to keep those aspects in mind. Okay, a brief outline here. I'd like to start by identifying the key data access points for users for GO-BGC data. And then we'll discuss navigating the Argo data system, as all GO-BGC floats are Argo floats. We'll talk a bit about the BGC and core system structure within Argo, data access and file types, and key takeaways, including directing you to the use of the synthetic profile files or SProfile files within Argo. That will be your best bet for BGC data access within the Argo system. Then I'd like to circle back to some additional features of data management within the internal GO-BGC program. We'll take a closer look at data flow among the collaborative institutions, how we use shipboard data, and then the derived products that we serve in different file formats outside of Argo. There are various points of access for GO-BGC float data, the first being through the Argo system. This option is desirable for global analyses as the Argo file system includes BGC floats deployed by all nations and programs, not just GO-BGC. There are various file types available, all of which use netcdf format. And again, most useful is the SProfile file, and I'll describe that file type in a bit more detail later in the talk. Just some key points up front. For the highest quality data within the SProfile file, you'll want to look for data adjusted in delayed mode with QC flag of 1. And one shortcoming of the Argo system is that there are no derived variables provided, although monthly archiving with GUI is a service that's provided to users. The GO-BGC team offers some additional data access options to users outside of the Argo system, and this includes our most timely option, which is the FloatViz ODV compatible ASCII file format, available on MBARI FTP. These files follow ODV quality flagging scheme, which differs from Argo, so you'll want to be looking for a flag of 0 for good data within this system. And these files have the added benefit of including derived carbon parameters directly in the files. And this goes for all floats produced by MBARI. We also serve both high-res and low-res data formats for users interested in high-res CTD measurements in addition to the more coarsely sensitive BGC data. We also provide regular archiving of our FloatViz ASCII file formats, and this is currently done through the UCSD Library Digital Commons. And as we've just set off with GO-BGC, this archiving is currently housed under the SOCOM umbrella, although we'll likely be changing that in the near future into separate archiving. Delayed mode QC with visual inspection is performed prior to the wrapping of each archive. So really for the highest quality data, including derived carbon parameters, this will be your best option for use in publications. I've added the timeliness of the different file types here just to kind of exemplify some of the differences between the different file access points. There's trade-offs among the different access points, but really if you're not interested in the derived carbon parameters, the Argo data system is going to be your most comprehensive access point. So now that I've introduced you to the different ways you can access data from the GO-BGC array, I thought we'd jump into some more details about the different file systems available, starting with the Argo system. As I mentioned before, all GO-BGC floats are Argo floats. And the image on the right here shows the initial deployments of the GO-BGC program in the North Atlantic. And this map was made using the interactive tool from the Argo Information Center at Ocean Ops. And it's just here to demonstrate to you that there's a lot of tools and options out there for exploring the different data and floats that are accessible through the Argo system. So 12 floats have been deployed thus far through GO-BGC, but there are many more biogeochemical Argo floats operational within the global ocean. The BGC Argo array is expanding, and the U.S. is a major contributor, but there's lots of data out there from other data assembly centers, or DACs. So again, this is why accessing data through the Argo system provides that added benefit of getting data outside of the GO-BGC program, as well as within. The two maps here show all of the Argo floats that are operational. The top one shows floats listed by float type. So the BGC floats that exist currently are in green. There's 402 listed there. And then below that image is an image of all floats listed by Data Assembly Center. So the U.S. contribution is in green, and the GO-BGC array will continue to contribute to the U.S. BGC Argo contribution. This slide provides some information on the international data management structure of the Argo system. Floats send their measurements to one of the 11 regional data assembly centers, and the data streams are processed, QC'd, and sent to one of the 2 global data assembly centers, or GDACs, the final data repositories for users. There's one that exists in the USA, that's FinMock, and then there's Coriolis in France. Again, this is where the users can access the data. There are 5 regional Argo centers and an Argo Information Center at Ocean Ops, which registers floats and serves as an info hub for metadata and visualization tools, as I previously mentioned. The Argo data system maintains a free and open data policy, so all data is available to the user as soon as it's processed. There are 2 Argo data streams, all files within our NetCDF. There's the real-time data stream with a target data latency of less than 24 hours. And these data are subject to automatic QC tests, flagging, and adjustments. And the goal here really is for the data to be good enough for use in operational applications. There's also the delayed mode data stream, where careful review of the time series is performed in comparison to reference data. Adjustments are derived, applied, and then propagated forward in real time. This analysis is performed at least once per year, and more often is certainly required for biogeochemical data. And the goal here is for use more so in scientific applications. The core Argo data system has been around for over 20 years, whereas the BGC data system is much younger. So the core Argo data system was extended to fit BGC data. Separate files are maintained. Core files contain pressure, temperature, and salinity, whereas B files can contain any combination of the BGC parameters: oxygen, nitrate, pH, chlorophyll, backscatter, and irradiance. Each file type shares a common pressure axis. It's important to note that data management is quite a bit more complex for BGC data. All BGC data requires adjustment in real time prior to use. This is not the case for core data, where much of the data, temperature and salinity data, is fit for scientific applications without adjustment. BGC adjustment procedures are still under development, and BGC Argo data managers are really working hard to increase the amount of adjusted data at the GDACs and to standardize adjustment methods across DACs so that we can more quickly get the highest quality data out to the users. A few key points here to note on the side is, again, the use of the SProfile files. This is your best source for BGC. Always look for delayed mode adjusted data. And another note is that all raw data is preserved within the Argo system for reprocessing and investigation for the user. Key to the Argo data system is the Argo data management team that supports it. This is a group of DAC representatives as well as scientists that meet once per year to discuss and progress aspects of the data system, including format, processing, and quality control methods, as well as sensor issues and sensor development. The two ADMT co-chairs are Sylvie Poliquin and Megan Skanderbeg, and the ADMT BGC co-chairs include myself and Catherine. One of the main goals of the Argo data management team is to find efficient ways to increase the level of high-quality adjusted data at the GDAC. So there's a lot of sharing of tools and methods for quality control that goes on, as well as the recent development of system-wide parameter audits for key parameters. The plots on the upper right, produced by Henry Bittig, show summaries of the amount of real-time adjusted and delayed mode BGC data through time for dissolved oxygen, nitrate, and pH. If we look at the plot on the left, we see back at the beginning of 2020, the amount of delayed mode profiles surpassed that of real time. So that was a big success for the Argo data management team, and it was due in large part to the implementation and adoption of the deoxy audit developed by Josh Plant. This audit detects anomalous profiles based on statistics of fleet-wide comparisons, float data to World Ocean Atlas climatology. And more recently, a similar audit has been developed by Raphael Saucedet for BBP data using a separate reference. So there's really a large-scale shared community effort across the DAC to improve the data system for the user. And we really want to continue to encourage users themselves to bring up issues with the data system that they find with DAC representatives and data managers. And we'd like to welcome users to stay involved with Argo data management. If you're ever interested in attending an ADMT meeting, you can always contact myself or one of the other co-chairs for more details. And visit the Argo data management website to stay up to date on Argo data management decisions, alerts, news, and updates. And it's also here where you'll find all the documentation on processing and QC protocols. And if you're a user that's completely new to the Argo system, I wanted to take the time to point out a few good resources for data access and just better understanding the background on the system in general. The Quick Start Guide, FAQs, a location of Argo monthly snapshot archives and description, and also what we like to call the nitty-gritty or again, a direct link for Argo documentation, cookbooks, QC manuals, etc. So I want to spend some time drilling into the details of the file system structure at the GDACs. And this should provide some background for those of you planning to attend the GO-BGC workshop data access tutorial. So there are two global data assembly centers worldwide, the French GDAC and the US GDAC, and I've provided the link to the FTP for each of those on this slide. The GDACs are mirrors of each other, so the file systems are identical at both locations. The main Argo directory is listed on the right for the Coriolis GDAC. Note that there are a number of index files available as well as different subdirectories that contain additional file types. So the various list files highlighted in red are really useful for subsetting the GDAC holdings by float, parameter, profile, etc. And I've mentioned the utility of the SProfile files numerous times in this talk. And so your SProf or synthetic profile index is going to be of great value to you if you're interested in BGC data. The SProfile Index essentially serves as a directory listing of all SProf files held at the GDAC. Data within includes information about DAX, WMO number, date of the file, location, ocean region, parameter, and data mode. So you can easily extract groupings of float based on the data mode you're looking for, the parameter you're looking for, the location you're looking for, etc. In addition to the index files are the different subdirectories holding additional file types. The auxdir holds any auxiliary data from experimental floats, and profile data, core and BGC, as well as the combined SProfile files, which I'll describe shortly here, are found in the dactyr. So that will be your go-to location. etc contains gray list subfiles and other miscellaneous files, and GEO holds data organized by ocean basin. As I mentioned, the DAC directory will be the subdirectory at the GDAC that you will likely access most often. Floats are organized by DAC and listed by WMO number. Each float directory holds the same set of file types. And we're going to drill down into an example for a US GO-BGC Apex float 5906342. So if we enter the AOML DAC directory, again, we see the floats are listed by WMO number. If we access float 5906342, we can see the contents of that floats folder. Again, each float directory holds the same set of file types. The trajectory file, the SProfile file, yay! The floats metafile, profile file, technical file, and the subdirectory containing individual profile files. So I've mentioned the SProf many times now, and you're probably a little bit curious to hear more about the details and why they're so exciting. Essentially, the SProfile files are your one-stop shop for core plus BGC data from a float. All cycles are combined into one file, and this only occurs for the BGC floats, the SProfile files, that is. The file updates are performed daily at the GDAC. So any new cycle coming in will then be appended essentially to the single SProfile file. These SProfile files are essentially an upgrade from the previous MProf or merged profile format that simply merged the core and BGC files without accounting for cases where measurements of multiple sensors were not aligned during onboard processing. And that made it difficult to study the BGC parameters as co-located measurements with core data. And it also made for very large file sizes with a lot of empty space. So with the SProfile files, the core and BGC parameters are aligned on one common pressure axis. So the goals are to co-locate as many BGC observations as possible while preserving the character of the sampling pattern. And it's important to note that no intermediate BGC parameters are included, only the main BGC parameters. If you want to read up on the details of how the SProfile files are generated and the interpolations are done, you can access the BGC Argo Synthetic Profile File Processing and Format document. On the right, I have an image from this document that exemplifies how the interpolations are done to bring the core and BGC data onto a single synthetic axis. And this makes managing the data and using the data and performing analyses much, much easier for the user. So the main point here is that the SProfile files were designed specifically to facilitate widespread use of BGC data. So please use the SProfile files. You won't regret it. I'd like to talk a bit more about some key information within Argo profile files, including the SProfile files, as well as the single profile files. So I mentioned how you should always be looking for adjusted fields when you are working with BGC data. Each parameter within a file will have an adjusted counterpart if the data has been adjusted in delayed mode or real time. Adjusted fields are initially derived using delayed mode quality control tools. For example, the SAGE and SAGE-02 tools as described in Maurer et al. In review. In addition to the adjusted data fields, the scientific calibration fields are also included within the SProfile files and profile files. These contain more information on the adjustments that have been applied, the equations used, coefficients used, and/or comments describing the method. Last, again, you really need to pay attention to the data quality flags. These are held under parameter adjusted QC or parameter QC. In Argo, you always want to be looking for good data, which is quality flag of 1. All raw BGC data prior to receiving adjustments, either in real time or delayed mode, will receive a flag of 3 for questionable. Another key field within the SProfile file, as well as the single profile file, is the parameter data mode. This exists for each parameter and can be either R for real-time raw, A for real-time adjusted, or D for delayed mode adjusted. If we look at nitrate for an example, if the only fields present are nitrate and nitrate QC, and no adjusted data is present, then the data mode is R. If adjusted fields are present, such as nitrate adjusted QC, and nitrate adjusted error, then the data mode is either A for real-time adjusted or D for delayed mode adjusted, and the parameter data mode would indicate which. Also note that the error fields, nitrate adjusted error, are only present for adjusted data. This provides an uncertainty measure of the adjusted data. Also note that any data that's been adjusted in delayed mode is assumed to have less uncertainty than data that's been adjusted in real time, with real-time adjustments propagated forward. As mentioned previously in this talk, for the highest quality data within the SProfile files, you'll want to look for delayed mode adjusted data, parameter data mode D. This is data that has been visually inspected and carefully reviewed using various methods, such as the SAGE tools developed at MBARI, which are used to compare oxygen, nitrate, and pH data against reference fields over the lifetime of the float. Important to note that a float can receive a delayed mode quality assessment multiple times throughout its life. When a float is first deployed, data gets sent to the DAC in real time without adjustments. Parameter data mode raw. For a BGC float, initial delayed mode quality assessments are performed early in life, around the 5th or 6th cycle. The assessment is performed, adjustments are derived and applied to the data. Data receives parameter data mode D, and the adjustments get propagated forward in real time for incoming data, receiving parameter data mode A. Subsequent delayed mode assessments can be performed later on in the float's life when more data is available to assess the time series. If new adjustments are derived, data can be reprocessed with parameter data mode D, and the new adjustments then get propagated forward again in real time. Note that both R and D adjusted data provide improved accuracy, but the lowest uncertainties in data are in data that has been delayed mode adjusted. Also note that drift adjustments are never propagated forward in real time. Now that you know a little bit more about the SProfile format and things to look out for, we hope you'll start using the data. The SProfile files are easily ingested into Ocean Data View for visualization, as well as other software packages such as MATLAB, R, and Python. The plot below I created using Ocean Data View by sucking in all SProfile files across the entire Argo network. The plot is of oxygen percent saturation over time for the upper 50 meters, and I selected only QC equals 1 across all DACs. It's clear to see that there are certain areas that likely require further assessment from the DACs. These floats above 150% saturation are likely incorrect. There's still a bit of work to be done. BGC Argo data management is in its infancy. And I just wanted to make the point that, wise users should really look carefully at data. Additional QC may be required, and never hesitate to contact myself or other DAC managers if you have questions about the data. So we've spent quite a bit of time on the Argo data system in general, and specifically the SProfile files. And I wanted to cover a few other file types that are available within the Argo data system that may be of use to users. First, the Metaphiles. The Argo Metaphiles are available 1 per float. And for GO-BGC and other MBARI process BGC data, the Metaphiles are produced by AOML. These include info on launch and mission configuration, parameter accuracy and resolution, redeployment calibration, onboard sensor types such as sensor make and model, project PI, transmission type, and more. The plot on the left I created through OceanOps, and it displays the number of floats in the Argo system by sensor type. So this is just to emphasize that although there may be a large number of floats, for example, with dissolved oxygen, this may be further subset by sensor type. For example, SBE 63 optode and NDERA optode. And if you're interested in looking at specific sensor types, the Metaphiles would be your source for extracting that information. The file type I'd like to mention is the trajectory file. Again, for MBARI process BGC floats, the trajectory file is produced by AOML and includes float timing info and parked drift and surface measurements. Optode in-air measurements that are used in calibration should also be stored here. Historically, these have been kept in the separate btraj file for BGC trajectory data. AOML historically has not produced the btraj file, but Argo is moving toward a single combined file, which will include core and BGC trajectory information. And we are actively working on getting this finalized. The last file type I want to mention within the Argo system is the Argo technical file. Again, there's 1 file per float, and these are also produced by AOML for the MBARI BGC process floats. These files include detailed information on engineering data from the float. So we've spent quite a bit of time on the Argo data system, which MBARI is heavily involved in. And as I mentioned, all GO-BGC floats are Argo floats. But I'd like to take a step back and kind of focus a bit on our internal data management structure and what we do to keep data flowing at the program level. There's a lot of resources available to you that are not within the Argo system that I would like to touch on and make sure that you're aware of. So the data flow for the GO-BGC program is a multi-institutional effort. The diagram on the right tracks the flow of data from float to end user. 3 institutions are responsible for float deployments and transfer of raw data: UW, HUI, and SIO. AOML in Miami performs the processing of real-time pressure, temperature, and salinity data, as well as the different file types we just discussed, meta, trajectory, and technical files. It's important to note that the University of Washington performs the delayed mode assessment of the core data and feeds that back into the data stream for Argo. As many of you are aware, MBARI performs the real-time and delayed mode processing of BGC parameter data. Scripps Institute of Oceanography assists with float and shipboard status data tracking. And there are multiple products and tools available to users, which we'll discuss in the following slides. If you are new to GO-BGC, our program website is a great place to start for reviewing all tools and data access points available, including the interactive map, which will plot the float track and current location of all operational and non-operational GO-BGC floats, as well as our status tables maintained by SIO, which show the current latitude, longitude, as well as additional information on float health. Another aspect of data management within the GO-BGC program is our use of shipboard data. This comes from casts taken alongside deployments and is used mainly for validation and not direct calibration. QC and standardization of shipboard data is managed at SIO, and data is archived at CCHDO and NASA CBAS. This is a community resource for climatology, algorithm development, and QC validation. And for GO-BGC, our goal is to get at least 50% of floats to have shipboard casts taken during deployment. And shipboard data is used mainly for validation, not direct calibration of quality control methods. And continued float-to-bottle matchups support routine assessment of fleet-wide accuracy and provide metrics for which to track the quality of the data through time and as we progress through the program. I mentioned early on in the talk that the MBARI FloatViz ASCII file products contain derived carbon parameters. These are computed in-house for consistency across the user base and include particulate organic carbon, total alkalinity, DIC, and PCO2. In the future, we may serve toolboxes such that users can begin to compute these parameters in a similar manner for floats outside of our system. I'd also like to point out that calculations for DIC and PCO2 involving CO2 cis require accurate float pH measurements. This is described in more detail in the pH talk. Again, we've talked a lot about the Argo system, so I just wanted to emphasize again that the derived carbon parameters are only available through the MBARI processed pathway. Derived carbon parameters are currently only available from MBARI processed BGC Argo floats, so this includes all GO-BGC floats as well as floats within the SOCOM program and other MBARI process floats. There are different points of access for the carbon parameters and the different file formats that we provide. These are accessible through the MBARI FTP, the SIO weekly snapshots, which include Metaphiles and NetCDF formats, as well as the triannual archives with DOI that are served through the UCSD Library Digital Commons. So thanks for listening, and I hope you've enjoyed this introduction to the GO-BGC data management and Argo systems. I understand that the data management system is complex, so if you have a question, don't hesitate to ask. Within the Argo system, a few key points to take away are that the synthetic profile files, or SProfile files, are really your easiest way for BGC data access. Only use profiles with adjusted BGC data, so parameter adjusted. And for data adjusted in delayed mode, use parameter data mode D. Only use data with quality flag of 1 or 2. And remember that there are many resources available through the GO-BGC website. For derived parameters, use the Embari served FloatViz products. And I know it seems obvious, but really always look at the data, explore the data. BGC Argo data management is in its infancy. We've come a long way in the past few years in bringing high quality data to users, but there's still a ways to go. So trust in the system, but please do your best to verify. And of course, if you have a question, don't hesitate to reach out. So on behalf of myself and the GO-BGC data management team, thanks very much for listening and for your interest in the program. Have a great day.